Today we're talking about direct variation. You're going to be hearing the phrase varies directly a lot. And most of the time you're going to hear y varies directly with x. A direct variation is always in the form y equals kx. Now k is called the constant of variation. Constant of variation. So when you see an equation in the form y equals kx, k is going to be a number. It could be y equals 2x, or it might be y equals negative 3x. It could be fractions, so y equals 1/2 x, or even y equals negative 7/5x. You get the idea. But y equals some number times x. Now let's talk about what it means to be a direct variation. Let's look at the equation y equals 2x. Let's make a table. In the x column, let's let x be 1. So if I plug that into my equation, I have y equals 2 times 1, so the y value would be 2. Now let's let x be 2. If I plug in x into my equation, I have y equals 2 times 2, which gives me 4. Now we want to look at the relationship between the x's and the y's. If I'm looking at the x column, I see that if I want to go from 1 to 2, this is multiplying by 2. Now what you'll notice is the exact same thing happens in the y column. To get from 2 to 4, you multiply by 2. Okay, now let's look at another equation that's similar. Look at y equals 3x. Making our table, I have x, y. Let's let x be 1. If I plug in a 1 for x, 3 times 1 is 3, so y equals 3. Now, let's let x be 2. 2, plugging into our equation, we get 3 times 2 is 6. Now again, look at the relationship in the x column. From 1 to 2, you multiply by 2, and the same thing happens in the y column. From 3 to 6, you multiply by 2. 3 times 2 gives you 6. Now the same thing happens if you're using fractions. If I have y equals 1/2 x, if this is my equation, and I make a table, x's and y's, let's let x be 1. So 1/2 times 1 is 1/2. Now let's let x be 2. Well, 2 times 1/2 gives me 1. Well, look at this equation here. Looking at the x column, 1 times 2 gives me 2, and again, 1/2 times 2 gives me 1. So hopefully everyone here is able to see the relationship that you're finding in a direct variation. Most of the time when you see a direct variation, you're going to see it in the form y equals k times x. Now sometimes they rearrange it to confuse you. So let's look at the equation y equals 2x again. Okay, this is a direct variation in the form y equals kx. Here, k is 2, so 2 is the constant of variation. Now what they'll do is they'll take that equation, y equals 2x, and they'll rearrange it in a way that doesn't look familiar to you. So what they might do is they might divide by 2 on each side. So if you divide by 2 on each side, then here those 2's cancel out. So you are left with y over 2 equals x. So that's one way you might see a direct variation. Another thing that they might do, if you have y equals 2x, is instead of dividing by the 2, they might divide by the x. So here the x's cancel out on the right hand side, and you're left with y over x equals 2. So they look a little bit different, but these are also direct variation. All they did is rearrange the problem. So let's look at two equations. One equation is a direct variation, and the other one is not. What we're going to do is we're going to create a table and decide which one is the direct variation. So this first equation, I have x times y equals 3. So I'm going to make a table. So here's x and y. Now let's allow x to be 1. So if x is 1 in our equation, 1 times y has to equal 3. That means that y must be 3. So now let's let x be 3. If x is 3, then x times y has to equal 3. That means y must be 1. So look at your relationship in the x column. To get from 1 to 3, I have to multiply by 3. In the y column, to get from 3 to 1, I have to divide by 3 or multiply by 1/3. That's different than what we've seen before. So this is not a direct variation. Look at the second example. Okay, again we're going to make a table. Let's let x be 1 this time. So I know something, y, divided by 1 has to equal 3. Well, I know 3 divided by 1 equals 3, so y must be 3. And now let's let x be 3. Well, if x is 3, then look at the y value. So y divided by 3 has to equal 3. Well, 9 divided by 3 is 3. Okay, so looking at my x column, to get from 1 to 3, I have to multiply by 3. To get from 3 to 9, I also multiply by 3. So this is the pattern that we saw before. You have to multiply by the same thing in each column. So yes, this is a direct variation. Right, this problem says if y varies directly with x and x equals 6 when y equals 12, what is y when x equals 4? What we're going to do is we're going to set this up as two separate problems. The first thing that's important is to know that y varies directly with x. That means we're going to use the equation y equals kx. Now, setting it into two problems, first piece of information that they gave me was that x equals 6 when y equals 12. So x equals 6 and y equals 12. So I'm going to plug these numbers into our equation and solve for k. So here it says y equals kx. Well, instead of y, we're going to replace it with a 12. So 12 equals, now I don't know what k is, so I'm going to go ahead and continue to keep the k. And then it says times x. So times x is 6. So I know 12 equals k times 6. Well, knowing your algebra, knowing your multiplication tables, you already know that 6 times 2 would give you 12. So k must equal 2. Now I already know my constant of variation. Okay, here's the second part of that problem. It says, what is y when x equals 4? So we're going to use our equation again. Y equals kx. That's a little bit hard to see. Let me change colors. Maybe orange is better. Okay, y equals kx. So what we're going to do is use the information that they gave us. Y, we don't know what it is. They told us to find y. But they did tell us that x equals 4. We also know from what we found out in the previous problem that k equals 2. So if I plug into this equation y equals kx, I don't know what y is, so the y stays. But I do know that k is 2, and I know that x is 4. So I have y equals k times x. So y equals 8. And there's the solution to that problem. Let's try one more. If y varies directly with x and y equals 20 when x equals 40, what is x when y equals 3? So we're going to begin the same way. We're going to say y equals kx. We know that that's our equation. And we're going to start with the first piece of information. So I know that y equals 20 and x equals 40. So plugging it into the equation, since y is 20, I have 20 equals k, I don't know what k is, times x, which is 40. Alright, well, I know that 40 times something has to equal 20. Now, one way that you can get this, if you already know in your head, you can see that 40 times 1/2 gives you 20. So I know that k must equal 1/2. You can also do this by saying, okay, well, the opposite of multiplying by 40 is dividing by 40. So I can divide each side of the equation by 40. So those 40s cancel out, and 20 over 40 reduces to 1/2. So you have 1/2 equals k, or k equals 1/2. Now take the second part of the problem. Again, we're going to use y equals kx, but now it says, what is x when y equals 3? Well, I don't know what x is, but I know that y equals 3, and I also know from the previous part of the problem that k equals 1/2. So I'm plugging into our equation. Y is 3 equals k is 1/2 times x. Well, I still don't know what x is. Okay, so 3 times 3 equals half of something. Well, I know by looking at that, I know that x must be 6, because half of 6 gives me 3. If you're not sure, remember the opposite of multiplying by 1/2 is multiplying by 2. So I could multiply each side of the equation by 2, and I get 6 equals x, or x equals 6. We'll have a lot of practice on this tomorrow. We'll see you then.